Hello viewers, in today's class we are going to discuss one important definite integral involving signum function, right? So viewers, here we have to evaluate an important definite integral that is from 0 to 2 pi sine x and signum of sine x dx, right? So here we'll evaluate this integral. Right now, before proceeding further, let us first define, or let us first take a quick look at the definition of signum function. Now we know that signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0, right? So this is the standard definition of signum function, and we have already dealt with this definition in our earlier lectures, right? Okay, so now let us apply this definition to signum of sine x, right? So what we will do, will replace this y by sine x, right? So signum of sine x is equal to plus 1 whenever this sine x is greater than 0, right? And signum of sine x is equal to 0 whenever sine x is equal to 0, and signum of sine x is equal to minus 1 whenever sine x is less than 0, right? So signum of sine x can be defined this way, right? Okay, now here let us discuss the function sine x, right? Because to evaluate this integral, we have to know the sign convention regarding the sine function in the 4 quadrants, right? So see, if we take the quadrants like this, this is x-axis, and this is y-axis, and let us take the rough sketch of sine function, right? So the sine function, it looks like this, and this is just a rough sketch, and here we have minus 1, and here we have plus 1, right? And here we have these points are pi, and here we have 2 pi, and so on, and this point is pi over 2, and this point is 3 pi by 2, right? So this is the rough sketch of sine function, and we know that whenever sine x is positive, whenever x lies in the first quadrant and the second quadrant, right? And sine x is negative whenever x lies in the third and fourth quadrant, and this fact is quite evident from the graph, right? From 0 to pi, that is whenever x lies between 0 and pi, then the value of sine x is positive, right? And whenever we go from pi to 2 pi, that is whenever x is greater than pi and less than 2 pi, it means this angle, that is x, it lies either in the third quadrant or in the fourth quadrant. So sine x is a negative quantity in the third and fourth quadrant, right? And moreover, see here we have sine x is equal to 0, right? And sine x is equal to 0 is a trigonometric equation, and it has the solution x is equal to n pi, right? Where n belongs to the set of integers, right? So whenever x is 0, pi, 2 pi, 3 pi, and so on, or we can also take the negative integers, so minus pi, minus 2 pi, minus 3 pi, and so on, then the value of sine x is 0. So sine x is 0 at these points, that is 0, pi, then 2 pi, 3 pi, and here in the negative x-axis we have minus pi, minus 2 pi, minus 3 pi, and so on, right? Okay, so sine x is greater than 0 whenever x lies in the first and second quadrant. Sine x is equal to 0 whenever x is equal to an integer multiple of pi, and sine x is less than 0 whenever x it lies in the third and fourth quadrant, right? So now let us split this integral as a sum of two integrals. So now here we have to integrate from 0 to 2 pi, and here we have pi. So now we can split this integral from 0 to pi and from pi to 2 pi, right? And when we go from 0 to pi, then the value of signum of sine x is equal to positive 1, right? And when we go from pi to 2 pi, then the value of signum of sine x is equal to minus 1, right? And at this point, that is pi, we have sine pi is equal to 0, so therefore sine x is equal to 0. So signum of sine x is equal to 0 when sine x is equal to 0. So the breaking point of the limits is x is equal to pi, right? So now let us call this integral as I. So now I is equal to 0 to pi, then we have sine x, then we have signum of sine x dx, and we have pi to 2 pi, then we have sine x, signum of sine x dx, right? Okay, so now we can write for this signum of sine x we can write positive 1, and for this signum of sine x we can write negative 1, right? So we have 0 to pi, then we have sine x, and here we have plus 1 dx, plus 1 for signum of sine x, and here we have pi to 2 pi, then we have sine x, and for signum of sine x we can write minus 1, right? So now we have 0 to pi sine x dx, and this is minus pi to 2 pi, then we have sine x dx, right? And the integral of sine x is minus cos x. So now the integral of sine x is equal to minus cos x. So therefore we can write this integral as minus cos x, and the limits are from 0 to pi. Then we have here minus cos x, and the limits are from pi to 2 pi, right? Now we can substitute the limits here, and we'll take the difference. So we have minus cos pi plus cos 0, and here this minus and minus becomes plus, so we have now cos 2 pi minus cos of pi, right? And cos of pi is minus 1, and cos 0 is 1, and cos 2 pi is 1 and cos pi is minus 1. So this is minus minus plus, so we have 1 plus 1, and here we have 1 minus minus plus, so we have 1 plus 1. So we have 2 plus 2, that is 4, right? So the value of this integral is equal to 4.